Okay, so let's look at this example here. So notice that we have something that has a square root in the denominator. So immediately I'm thinking, well, one, you automatically want to think of a u substitution. But in this case, we can't do a u substitution because if we make u the radicand, there's no x up here. So we can't do a u substitution. This is a candidate for a trig substitution. In fact, that's the only way we can do this is using a trig substitution. So we notice that it has the a squared minus u squared or x squared here. So this is going to be inverse sine because it has that form. So in this case, a is equal to 1, right? And u is equal to x. And so what happens is, remember, it's going to be the integral of this thing is inverse sine of what? X over a. But a is 1. So it's just going to be the inverse sine of x. Okay, so all I'm going to do is I'm going to rewrite this as I'm going to rewrite this as sine inverse of x, and we're evaluating because it's a definite integral, so we're evaluating from 0 to 1. And so now all I have to do is put it in there, right? So I have to evaluate this based on the integral. Okay, so let's do it. All I'm going to do is just, again, I'm going to say, okay, this is going to be the inverse sine of 1 minus inverse sine of 0. Okay? Okay, so what are we looking at here? So they're inverse trig functions, right? So they're angles. So what the sine of what angle will give me 1, right? Pi over 2, right? And then here, we ask ourselves, the sine of what angle gives me 0? And that's 0. And so the answer is pi over 2. Okay, so here's one for you. How about this one? So we got this integral that I want you to evaluate. Try that one. So do that one, and if you want, email me and for confirmation of how you did. Or if you have a question or if you get stuck on how to do it, let me know. I'll be more happy to help you. Okay, that's it. See you next time.